There is a quiet question that drifts through every age of humanity, a question older than maps, older than cities, older than the first stories drawn in firelight. When we look up at the night sky, are we seeing a universe filled with life, or a beautiful, endless silence? Some nights the stars feel close enough to touch, and we wonder whether another mind, somewhere far away, is wondering the same thing. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the sky from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together beneath the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let your shoulders soften, feel the quiet settle in the room. The night around you becomes a soft ocean, carrying your thoughts like slow waves, and together we begin tonight's voyage into the quiet story of whether we are truly alone in the universe. This question isn't loud. It doesn't demand an answer. It simply hovers, like a faint shimmer on the horizon of human curiosity. For tens of thousands of years, our ancestors looked into the darkness with the same mixture of wonder and tenderness that you feel now. The universe has always invited us to dream a little bigger than ourselves. As we breathe, imagine the stars above you stretching across billions of miles, silent, steady, patient. Each one is a sun. Some cradle worlds, some worlds may hold oceans, and on some distant shore, perhaps life has taken a breath, just as you are breathing now. Maybe there are minds shaped by chemistry we've never seen, languages woven from frequencies our ears can't hear, civilizations that think in colours, or in vibrations, or in slow currents of magnetic light. Or perhaps the cosmos is still in its early chapters, and we are among the first tiny sparks of awareness to wake up in the vastness. Tonight, you don't need to solve this mystery, you only need to drift with it. Let the idea move softly through you, that the universe could be full of hidden stories, unfolding in silence, waiting for someone to listen. Your breath slows, your thoughts loosen. The question becomes a lullaby, carried gently across the dark sea of stars. You are safe. You are small in the best possible way, and the universe, whether watched by countless eyes or only ours, continues its quiet shimmering all the same. This is our beginning. A single inhale at the edge of an endless sky. There is a reason this question has followed humanity across centuries, whispered through philosophy, astronomy, myths, and quiet night thoughts. Are we alone? It is more than a scientific curiosity. It's a mirror held gently to our sense of meaning. When you ask whether life exists beyond Earth, you're also asking something about yourself. What does it mean to be here? What does it mean to be aware? And why does the universe feel so impossibly large for only one species to witness it? Every civilization that has ever lifted its eyes to the sky has wondered the same thing. Ancient navigators spoke of spirits wandering between the stars. Poets imagined distant realms filled with minds shaped by different suns. Scientists built telescopes to turn that wondering into data. And even now, with spacecraft exploring nearby worlds and observatories listening to the deep, radio quiet of the cosmos, the question remains beautifully open, like a window without a frame. Humans ask this question because we are born between two immensities, the smallness of our bodies and the vastness of the night. There is something tender about realizing how tiny we are, yet how capable we are of imagining worlds that may never touch us. The longing doesn't come from fear. It comes from a quiet desire to know that life is not an accident, but a pattern the universe enjoys repeating. Sometimes, in moments of stillness, the question drifts into something softer. If there are others out there, Do they wonder too? Do they look up at their skies and feel the same ache of curiosity? Do they have oceans, or forests, or chemical seas glowing in alien night? Do they wonder whether intelligence is rare, or whether awareness blooms everywhere light can reach? And perhaps the deeper question beneath it all is this: is loneliness part of the human condition, or just part of our infancy as a species? If the universe is teeming with life, then we are children standing at the doorstep of something grand and overwhelmingly beautiful. If it is empty, then we are a unique spark, a solitary flame moving through cosmic darkness, carrying the weight of consciousness on our small blue world. But either way, the question matters. It stretches the boundaries of imagination. It invites us to explore with humility rather than conquest. It teaches us to listen, not only to signals from the stars, but to the quiet signals within ourselves. When we wonder about other worlds, we learn to appreciate our own world more deeply. When we imagine other minds, we become gentler with our own. Tonight, this question will guide our journey, not with urgency, and not with the pressure to find a final answer, but with the same slow curiosity that starlight uses to cross the void. There is no rush. There is only wonder, unfolding one breath at a time. As you settle deeper into stillness, feel how the question begins to soften. Let it move through you like a tide, not demanding resolution, only inviting presence. You are not required to reach the end. You are simply invited to float. To search for life beyond Earth is to look for something we have never seen, using tools built from what we already know. It is a gentle paradox. We seek the unfamiliar through the familiar, hope in the universe will meet us halfway with patterns we can recognize, or at least interpret. And so, humanity has learned to read the cosmos the way one might read a distant shoreline through fog, not by shapes, but by hints, by echoes, by soft regularities hidden in the noise. Our search begins with light, because light is the universe's oldest storyteller. Every star sends out thin ribbons of information that drift across space for thousands, sometimes millions of years. When these rays reach our telescopes, they carry subtle fingerprints of any planets that orbit nearby. A tiny dip in brightness, a faint wobble, a slight shift in colour. These are the clues that tell us another world is there, circling quietly in the dark. But the search goes deeper than planets. We look for atmospheres, for the delicate breath of a world. By spreading starlight into its rainbow of wavelengths, we can detect the presence of gases, oxygen, methane, water vapour, the building blocks of a possible biosphere. It's like listening for a whisper carried across interstellar winds. The whisper may be faint, but it is enough to make us wonder whether something, somewhere, is inhaling and exhaling beneath an alien sky. Yet detecting life means more than detecting chemistry. It means learning how to sense intelligence that may not resemble our own. On Earth, we once believed human language stood alone in complexity. But when computers analysed the chirps and whistles of dolphins, patterns emerged, mathematical regularities that revealed a structure completely different from human speech, yet undeniably intelligent. If machines can find meaning in the songs of creatures who do not share our biology, then perhaps one day they will find meaning in signals drifting from the stars, signals shaped by minds that think in ways beyond our imagination. Even silence holds data. Radio observatories listen to the cosmic background, hunting for anomalies that break nature's usual rhythms. Most signals turn out to be pulsars, static, satellites, or the Earth talking to itself. But every once in a while, something unusual flickers through the noise. A pulse too clean, a frequency too precise, a moment of structure where randomness should reign. It may not be a message. It may not be anything at all. But the universe has taught us that even a single strange moment is worth paying attention to. Our search is patient. It must be. The distances are vast, and life, if it exists, may reveal itself slowly. We are not scanning for aliens crouched behind craters or flying silver discs cutting across the sky. We are searching for patterns, for order, for the slight deviations in cosmic melody that hint at a conductor's hand. We are learning to listen not with expectation, but with openness. Tonight, as you breathe deeper, imagine those giant telescopes standing under the quiet night, waiting for faint signatures drifting across impossible distances. They do not rush, they do not demand, they simply listen, and so do we. In that stillness, the search becomes something beautiful, a reminder that even without answers, curiosity itself is a form of connection. To imagine life beyond our planet, we often begin by looking backward rather than outward. The story of Earth's earliest days is more than a tale of our origins. It is a quiet blueprint, a soft sketch of the conditions under which life can awaken. And tonight, we drift gently into that ancient landscape, letting its memory guide our sense of what might bloom elsewhere in the cosmos. Picture the Earth more than 4 billion years ago. There are no trees, no continents shaped as we know them, no creatures walking beneath the sky. The oceans are young, warm and unsettled, stirred by volcanic heat and illuminated by lightning that flickers across a dense, hazy atmosphere. It is a world of energy and possibility, chaotic yet full of the ingredients that whisper life into being. In this primordial sea, chemistry does not rush. It drifts. Molecules float, collide, fall apart, and meet again. Over millions of years, simple patterns begin to form, the faintest suggestion of structure, like the first gentle rhythm in a long, quiet song. These molecules do not know they are becoming life. They do not strive or intend. They simply follow nature's soft inclination toward complexity, gathering into chains that can hold information, membranes that can protect it, and systems that can slowly learn to sustain themselves. It's humbling to think that everything alive today, every tree, every whale, every human breath, can trace its lineage back to these humble beginnings. A tiny pocket of chemistry, balanced just right, guarded by chance, and nurtured by time. And as we reflect on this, another thought arises like a slow tide. If such conditions could happen here, in a small corner of an ordinary galaxy, then perhaps they could happen anywhere. Life, as far as we can tell, does not require magic. It requires opportunity, water in liquid form, stable energy, organic molecules drifting and dancing under the right temperatures. These are not rare ingredients. In fact, they appear to be scattered generously across the universe, hidden beneath icy crusts, floating in nebulae, stitched into meteorites that fall onto worlds waiting for a spark. When astronomers search for life, they are not looking for cities or civilizations first. They are looking for the quiet chemistry of youth, worlds wrapped in oceans, warmed by stars, shaped by geology that can breathe. They are looking for Earth-like beginnings, because Earth itself showed us that complexity can emerge slowly, shyly, from the simplest materials. And so, understanding early Earth becomes a lantern held at the entrance of a vast unknown. It illuminates the kinds of places where life may start, not in gleaming laboratories or advanced technology, but in muddy shorelines, deep-sea vents, gentle pools warmed by volcanic heat. It reminds us that life, at its core, is patient. It grows in rhythms almost too slow to witness, yet persistent enough to shift a planet's future. As you rest deeper into the stillness of this moment, imagine those ancient oceans shimmering under a sky filled with unfamiliar colours. Imagine the first stirrings of life, small, fragile, unnoticed, beginning a journey that would one day lead to consciousness gazing back at the stars. In that image lies a quiet truth. If life could rise here, it may rise elsewhere, carried by the same cosmic currents that shaped us. When we imagine life taking root on distant worlds, we often picture something simple. A planet warmed gently by its star, turning slowly through a balanced cycle of day and night. Not too hot, not too cold. A place where water can rest in its liquid form, neither boiled away nor locked forever in ice. Astronomers call these regions habitable zones, but the name feels almost too clinical for something so quietly poetic. These are the Goldilocks zones, the gentle bands around stars where conditions settle into harmony. Every star has its own version of this delicate region. Around small, dim red dwarfs, the Goldilocks zone hugs close, like a whisper. Around huge, brilliant stars it stretches farther out, bathed in a wider glow. To find these zones is to trace the invisible warmth of a sun, imagining where a planet might orbit in comfort, cradling oceans or skies capable of sheltering chemistry. It's amazing how narrow these bands often are. A planet drifting just a little too close bakes beneath relentless radiation. A planet sliding a little too far away becomes a frozen sphere of silence. And yet, in this precarious balance, worlds like Earth emerge. Worlds where water traces riverbeds, where clouds form and dissolve, where temperature swings gently enough for life to find its rhythm. But the Goldilocks zone isn't the whole story. Some worlds may thrive outside it, warmed by internal heat, tidal forces, or chemical energy rather than sunlight. Still, when we search the galaxy, we begin with these bands of gentle equilibrium, not because we are sure life must arise there, but because life here did. Earth became a sanctuary because it orbited in a place where calm was possible, where chaos softened into cycles, and where temperature allowed molecules to meet, merge, and eventually remember. Imagine drifting above a distant star system, watching planets sweep their silent paths. Some glow with reflected light, shimmering like pearls. Some are dark, shrouded in storms. But somewhere in that cosmic dance, perhaps one world circles at just the right distance, a quiet blue dot beneath an alien sun. Maybe it has rainstorms that fall softly. Maybe it has winds that carry chemical scents across oceans. Maybe it waits patiently for life to bloom, just as Earth once waited. The Goldilocks zone is not a promise. It is an invitation, a hint that a world might be gentle enough for life to attempt its first small steps. It is a reminder that life is not fragile by nature. It is fragile in its beginnings, dependent on careful balances that allow complexity to unfold slowly and steadily, like a seed pushing through soil. As you breathe deeply now, imagine these zones as soft halos around countless stars. Imagine them shimmering across the galaxy like faint rings of possibility. If even a fraction of those halos cradle a world like ours, then the night sky holds far more than darkness. It holds potential. It holds stories waiting for their first chapter. Let your thoughts drift through those glowing bands of warmth. Let them wander to the idea that Earth's position is not a miracle of rarity, but a gentle echo of conditions that may repeat across the cosmos. In that echo lies hope. Not loud or urgent, but quiet and steady, like the pulse of your breathing. When we think of oceans in the universe, our minds often drift first to Earth, to the blue expanses that cover most of our planet, glimmering under the sun. But some of the most promising places for life may not resemble our familiar seas at all. They may lie hidden beneath miles of ice far from the comforting warmth of a star. These are the subsurface oceans, dark, silent worlds beneath frozen shells, and in their shadows the possibility of life quietly lingers. Take a moment to imagine Europa, one of Jupiter's moons. From afar it looks like a smooth marble of pale white and faint gold, streaked with long, cracked lines like the surface of old porcelain. But beneath that icy crust lies a global ocean, deeper than any ocean on Earth, vast enough to swallow mountains. There is no sunlight there, no sky, only black water warmed by the moon's internal heat, stirred by tidal flexing as Europa orbits its giant planet. And yet, where there is liquid water, chemistry can unfold. Where chemistry unfolds, the story of life can begin. Enceladus, a tiny moon of Saturn, tells a similar tale. Its surface gleams with snowy brightness, but from its south pole erupt towering plumes of water vapour, bursting into space like silent fountains. These plumes are more than beautiful. They reveal something profound. Beneath the ice, Enceladus also holds a warm, salty ocean. Inside it, organic molecules swirl, building blocks for life drifting in a place where light never touches. It is astonishing to think that two small moons, in the cold outskirts of our solar system, may carry oceans that breathe with energy. These hidden seas challenge our assumptions. They remind us that life does not require the gentle sunlight of a Goldilocks zone. It can thrive in darkness, warmed by internal heat, nourished by minerals, surviving in conditions that once seemed unfriendly to biology. Even on Earth, at the bottom of our deepest oceans where sunlight cannot reach, entire ecosystems bloom around hydrothermal vents. Bacteria feed on chemical energy, forming the base of food webs that support strange, beautiful creatures. Life, it seems, is creative. It adapts, it explores. And so we begin to see that the universe may cradle life not only in warm, Earth-like worlds, but also in shadowed oceans wrapped in ice. Worlds where light is scarce but potential is abundant. Worlds where life might begin not with sunlight, but with warmth from within. A quiet spark sheltered beneath layers of frozen silence. As you breathe slowly now, imagine floating through such a dark ocean, hearing only the hum of gentle currents and the distant creaking of ice shifting above you. Imagine the possibility that somewhere in those depths, simple organisms drift gracefully, unaware of stars or planets, living in a universe of water and warmth. They do not need sky to find purpose. They do not need sunlight to exist. They simply are, and that is enough. These subsurface oceans expand our sense of what life can be. They open the door to new realms of possibility, places where beginnings could unfold in complete darkness. And as we drift with this thought, we understand something quiet and profound. Life may not wait for perfect circumstances. It may only wait for a chance. If life is a conversation, then chemistry is its alphabet, a quiet set of rules that matter follows as it gathers, reacts and transforms. Across the universe, stars forge elements in their luminous cores. When those stars die, they scatter those elements into space like soft seeds on a cosmic wind. Carbon, hydrogen, oxygen, nitrogen. They drift through nebulae, settle onto young worlds and wait patiently for the right conditions to begin speaking the language of life. It is remarkable that the same elements that shape our bodies are found everywhere we look. The carbon in your cells was once carried inside a star. The oxygen in your lungs may have travelled through interstellar clouds. The nitrogen in your DNA comes from the life cycle of ancient suns. In a way, chemistry is the universe's handwriting, consistent, elegant, and quietly universal. When scientists search for life, they look first for these familiar letters: organic molecules, water, simple sugars, amino acids. These are the phrases nature repeats again and again, like a poem written across the galaxy. And even though life itself may take countless forms, the ingredients that make life possible seem to be scattered generously throughout space. Imagine drifting through a giant molecular cloud, a vast cold region where chemistry begins its slow unfolding. Within these clouds, simple molecules cling together, learning the first steps of complexity. Ultraviolet light from nearby stars adds energy, triggering new reactions. Ice-coated dust grains serve as tiny laboratories where atoms meet and embrace. Out of this quiet chaos, more intricate structures form. Nature has time. Billions of years. It experiments with patience. On young planets, these ingredients fall like a gentle rain. They mix with shallow waters, volcanic minerals, and shifting tides. This is where chemistry becomes something more, where patterns begin to reinforce themselves, where reactions learn to respond, where molecules stumble into self-sustaining cycles. Life does not begin with a sudden spark. It begins with a soft accumulation of possibility. Even now, scientists look for these chemical fingerprints on distant worlds. They search for methane balanced with oxygen, for water vapour wrapped around strange atmospheres, for the subtle imprints of processes that might only occur when life is present. These signals may be faint, a slight bend in starlight, an unusual spectral line, but they are enough to ignite curiosity. And beyond this scientific precision lies something more poetic, a sense that the universe may be humming with the same fundamental tune everywhere. Chemistry is not bound by culture or consciousness. It does not depend on shape or language. It simply follows its own elegant logic. And from that logic, complexity can rise, quietly, patiently, inevitably. As you breathe gently, imagine the universe as a vast book written in chemical sentences. Some pages are blank. Some are full of simple words. Some, we hope, contain the early lines of life's unfolding story. When we search for life beyond Earth, we're not looking for ourselves reflected back. We're looking for the familiar rhythm of chemistry, the soft universal patterns that hint that life may be practicing its ancient song elsewhere. The universe writes in atoms, life reads in molecules, and consciousness, drifting softly like yours in this moment, listens for meaning hidden in the quiet structure of things. To search for life in the universe, we often look not at the worlds themselves, but at the light that touches them. Starlight becomes our messenger, a thin, shimmering thread that travels across impossible distances to carry whispers of distant atmospheres, hidden oceans, and chemical secrets. And so, one of humanity's most beautiful skills is learning how to read light the way others read letters on a page. Every star emits light, but that light carries more information than brightness alone. When it passes through a planet's atmosphere, it changes, subtly, delicately, like ink absorbing into soft paper. Some wavelengths disappear, absorbed by gases floating above the planet's surface. Others scatter, creating a pattern of shadows and gleams. To the human eye, these differences are invisible, but to our instruments, patient, steady, precise, they are a language waiting to be understood. Imagine stretching a beam of starlight into a long, colourful ribbon. Reds blend into oranges, blues into violets. This ribbon, called a spectrum, is where the secrets lie. If oxygen is present in a planet's atmosphere, it leaves a distinct notch in the ribbon. If methane floats among the clouds, it carves out another. Water vapour, carbon dioxide, ozone, each one tugs at the light in its own unique way. Together, these signals paint a portrait of a world we may never visit, yet can still gently understand. When astronomers study these signatures, they are not simply looking for chemistry. They are listening for balance, for combinations of gases that should not coexist unless something, somewhere on that world, is replenishing them. On Earth, the presence of abundant oxygen is a direct result of life. Without living organisms, our atmosphere would drift back into equilibrium, losing its delicate imbalance. And so, when we look for distant life, we search for atmospheres out of balance, systems that behave as though something active, something dynamic is breathing beneath the sky. But reading starlight isn't only about detecting planets, it's also about observing motion. When a planet crosses in front of its star, the starlight dims slightly, a soft flutter in brightness, like a heartbeat detected across cosmic time. From that flutter we can measure a world's size, its orbit, even its temperature. Sometimes the starlight wobbles as the star itself shifts under the gravitational pull of its companion planet. That wobble becomes another clue, another thread woven into the tapestry of discovery. It's astonishing to think that from a faint dip in brightness or a slight tilt in colour, we can infer the existence of oceans, clouds, and winds on worlds light years away. We may not see these planets directly, but we sense them. We translate their starlight into meaning. In a way, we are learning to see with the eyes of the universe itself, tracing patterns that light has carried for centuries before reaching us. As you breathe slowly now, imagine yourself holding a piece of starlight, fragile, warm, ancient. Imagine spreading it gently into its rainbow form and discovering within its colours the story of a distant world. You do not need to understand every detail. You only need to sense the wonder of it, that somewhere in the quiet dark, a planet is turning, its atmosphere painting subtle messages across the light that journeys to your eyes. In this soft act of reading starlight, we become listeners in a cosmic conversation, patient and curious, waiting for the universe to reveal its secrets one wavelength at a time. When we study the atmospheres of distant worlds, we are doing something quietly poetic. We are listening for a planet's breath. Every world exhales in its own way. Some breathe out volcanic gases, painting their skies with thick veils of carbon dioxide. Others release gentle traces of water vapour, whispering of clouds drifting across alien horizons. A few, perhaps, exhale mixtures so surprising, so delicately balanced, that they hint at something more. The subtle rhythms of life shaping the air from within. A planet's atmosphere is not just a layer of gas. It is a story written in chemistry. On Earth, that story changed dramatically when life appeared. Early in our planet's history, the air was toxic, thick with methane, nitrogen, and carbon dioxide. But as tiny organisms learned to harness sunlight, they began releasing a new gas, oxygen, into the atmosphere. At first, it was only a whisper. Then it grew stronger, transforming the sky into something blue, breathable and alive. The air around you right now is the result of billions of years of biological activity, a quiet testimony to life's persistent creativity. This is why astronomers pay such close attention to the atmospheres of exoplanets. Certain combinations of gases simply shouldn't coexist unless something is actively replenishing them. On Earth, oxygen and methane would quickly destroy each other without living organisms constantly producing both. When scientists see this kind of imbalance in the atmosphere of a distant world, it sparks a soft, cautious hope. Perhaps something is breathing there too. And yet, detecting these gases is only the beginning. The real mystery lies in understanding them. A world rich in oxygen might be lush and vibrant, or it could be scorched and desolate, its oxygen produced by the breakdown of water under intense starlight. Methane might be created by microbes, or by geological activity bubbling under the surface. The universe speaks in a language that is subtle, layered, and often ambiguous. We must listen with patience. Still, the possibility is breathtaking. Imagine a planet silhouetted against the glow of its star as it passes in front. For a brief moment, starlight filters through its sky, carrying chemical traces of whatever drifts there. That light travels across light years of space before touching our telescopes. In those fragile photons lie the fingerprints of alien air, clues to temperature, clouds, pressure, and perhaps biology. When we read these fingerprints, we are not just analysing data. We are reaching across the void with curiosity, letting the breath of a distant world brush gently against our imaginations. We are wondering whether somewhere, far beyond our reach, a different kind of life is shaping its environment, influencing its skies, and participating in a story parallel to our own. As you relax deeper into stillness, imagine standing on a quiet hill beneath a night sky full of stars. Each point of light may be shining on a world with its own atmosphere, its own patterns of wind, clouds, and chemistry. Some may be barren, some may be waiting, and a few perhaps may be breathing softly into the dark, releasing delicate hints of their presence into the starlight that drifts our way. In listening to these faint signals, we are reminded of a gentle truth. Even worlds we cannot see can share their stories with us. All we need is patience, curiosity, and the quiet willingness to interpret the breath of a planet carried on the light of a distant sun. As we imagine the universe filled with vibrant planets, breathing atmospheres, and the first stirrings of alien life, we must also acknowledge the quieter truth. Most worlds we discover seem empty. They drift in their orbits without oceans, without warmth, without the delicate balance that allows chemistry to rise into something more. These barren planets remind us how fragile life truly is. How many conditions must fall into harmony before a single cell can take its first trembling step toward existence? Picture a rocky world locked in the eternal darkness, circling too far from its sun. Its surface is frozen solid, the atmosphere thin or non-existent, the landscape silent for billions of years. Winds do not blow, rivers never formed, no living thing has ever brushed across its surface. It is beautiful in its own way, a sculpture carved by time, but it carries none of the restless creativity that defines life. Then imagine another world too close to its star. Seas have boiled away, leaving vast salt plains that glitter under brutal radiation. Volcanic heat reshapes its crust repeatedly, but nothing softens that violence. This planet breathes fire instead of air. It is alive only in the geological sense, active, dynamic, yet empty of biology. It stands as a reminder that life is not guaranteed, even when the ingredients are present. Some worlds frustrate our hope in more subtle ways. They begin promisingly, with water, minerals and sunlight. But a sudden shift, a runaway greenhouse effect, a thinning magnetic field, a collision with a massive asteroid, erases their potential before it matures. These planets whisper a sobering truth. Life's beginnings can be undone by forces indifferent to its existence. Earth, too, faced these dangers in its youth. That we are here at all is a quiet miracle of timing. And yet, these empty worlds serve a purpose in our search for companionship. They teach us humility. They remind us that life is precious not because it is widespread, but because it is fragile. They show us that even a universe overflowing with stars may hold only a handful of places where life blooms. And those places are rare sanctuaries, small islands in a cosmic ocean. But emptiness also has its own beauty. A barren planet is not a failure. It's part of the natural diversity of worlds, each shaped by the subtle balance of gravity, light, and time. These silent spheres carry history etched into their rock, history we can learn from even if no living thing ever walked across their surface. Some may hold fossils of early chemistry, frozen snapshots of life that almost was. Others may hide ingredients waiting patiently for conditions to change. As you breathe softly now, imagine standing on the surface of one of these quiet planets. The sky arches above you in unfamiliar colours. The horizon stretches endlessly. There is no sound but the wind, or perhaps nothing at all. And in that silence you feel a strange peace. Life may not have taken root here, but the universe is no less full of wonder. Every empty world deepens the mystery. And perhaps, in drifting through these barren landscapes, we learn to appreciate our own world more deeply. A fragile sphere where conditions are lined just right, where oceans shimmer, where air moves gently through forests, and where consciousness emerged to ask questions beneath the stars. Every time astronomers discover a new planet outside our solar system, the universe feels a little less mysterious, not because it becomes smaller, but because we begin to see how vast and varied its worlds truly are. Each exoplanet is like a page in an enormous cosmic library, a record of the countless ways matter can assemble under the guidance of gravity and time. Tonight we drift through that library, letting its silent diversity expand the space within our imaginations. So far, we have found thousands of these distant worlds. Some orbit suns much like our own. Others circle stars that burn faintly red or fiercely blue. Some worlds skim so close to their stars that their surfaces glow with molten rock. Others move through darkness, orbiting so far away that their atmospheres freeze into crystal. There are planets made mostly of water, planets heavier than iron, planets with two suns rising together like twin lanterns. Each one is a reminder that our solar system is only one arrangement in a universe full of possibilities. Astronomers discover these planets through hints, tiny dips in starlight, faint gravitational tugs, gentle wobbles that reveal a companion hidden in the glow. It's like watching a ship pass behind a curtain and sensing its presence through the ripple it leaves. From these small clues, we infer astonishing details: the planet's size, its orbit, even the composition of its atmosphere. And slowly the library grows. There are hot Jupiters, massive gas giants that orbit closer to their stars than Mercury does to the Sun. Their skies are likely filled with harsh winds and shimmering heat, a constant storm without rest. There are super-Earths, rocky worlds larger than our own, perhaps with thicker atmospheres and deeper oceans. These planets tease us with the possibility that some may be habitable, or even more hospitable than Earth. Some of the most intriguing worlds are those in the Goldilocks zones of their stars, planets that sit in that delicate region where water can remain liquid. We imagine them with clouds drifting softly across alien skies, with oceans reflecting unfamiliar constellations. And even though most of these worlds remain silent to our instruments, their mere existence stirs a gentle curiosity. If there are so many planets, could even a fraction of them host life? With billions of stars in our galaxy and galaxies beyond counting, the number of potential homes for life becomes almost unimaginable. But the library of exoplanets carries another lesson. Diversity does not guarantee life, yet it deepens our understanding of what might be possible. Each world adds a new variation, a new story of how matter organizes itself under different conditions. Some stories may be brief, some may be turbulent, and a few perhaps may carry the first chapters of biology unfolding in quiet oceans or swirling atmospheres. As you breathe slowly now, imagine drifting through this library with no hurry, passing shelf after shelf of distant worlds. Some glow warmly under their stars, some lie in eternal night, some shimmer with potential. Each one whispers a small truth. The universe does not create just one kind of planet. It creates endlessly, generously, softly. And somewhere within this boundless diversity, the story of life may already be unfolding in ways we have yet to imagine, a reminder that possibility is as vast as the night sky itself. When we imagine encountering intelligence beyond Earth, we often default to the familiar, voices, languages, symbols, or technology, shaped by minds that think like ours. But the universe is under no obligation to mirror human thought. If intelligence exists elsewhere, it may express itself in forms we cannot predict, through frequencies, patterns, pulses, or rhythms that feel alien not because they are quiet, but because they are simply different. Understanding this requires humility. Even here on Earth, we once believed human language was uniquely complex, the only system capable of carrying layered meaning. But when scientists began using computers to analyze the sounds of dolphins, something extraordinary happened. What seemed like random squeaks and clicks revealed mathematical structure, patterns, repetitions, variations that hinted at an organized, purposeful form of communication. The dolphins had always been speaking. We simply didn't know how to listen. This realization carries a gentle lesson for our search beyond Earth. If we could not recognize intelligence in the waters of our own planet without the help of modern tools, how might we recognize intelligence shaped by a completely different biology, environment, or evolutionary path? What if alien communication is not built from sound, but from electromagnetic pulses? What if it is encoded in chemical changes, shifts in magnetic fields, or rhythmic bursts of radiation? Intelligence may not be loud. It may not be obvious. It may hide in plain sight within patterns we have not yet learned to interpret. And so, astronomers and physicists begin with the one principle that seems universal: order emerging from chaos. Nature creates randomness easily, but intelligence, even in its simplest forms, creates structure, patterns, repetition with variation, signals that hold meaning beyond their basic properties. Our instruments can search for these clues, sequences too regular to be natural, pulses arriving with the uncanny precision, or spectral changes that hint at purposeful modulation. This is not about expecting a message that says hello. It is about noticing when the universe behaves in ways that feel intentional, as though shaped by a mind that understands patterns and chooses to create them. It is about learning to recognize intelligence, not by its familiarity, but by its mathematical signature. In radio observatories around the world, massive dishes turn slowly across the sky, listening for those signatures. The data they collect looks like noise at first, static crackles, faint vibrations stretched thin across the fabric of space. But within that noise, analysts search for anomalies, an unusual spike, a consistent interval, a harmonic structure that repeats in a way nature rarely does. Each anomaly becomes a question, a possibility, a whisper asking to be examined. And sometimes the anomalies come from places we did not expect, from our oceans, from animals, from atmospheric phenomena. Each discovery teaches us something new about how diverse intelligence can be. Each new pattern expands our understanding of how minds might communicate across vast distances or through unfamiliar mediums. As you breathe gently now, imagine listening to the universe not with ears, but with intuition, sensing patterns in the darkness, recognizing that intelligence may reveal itself like a subtle melody woven into the static of existence. You do not need to decode the message. You only need to feel the wonder of knowing that if other minds are out there, they might already be speaking in ways we are just beginning to understand. When we contemplate intelligent life beyond Earth, it helps to imagine not just where life might exist, but how far it could advance. On our planet, technology has grown in small, fragile steps. Fire, agriculture, electricity, computers, each one a quiet turning point. But somewhere in the universe, if life has had a longer runway, more stable conditions, or simply different challenges, its progress might be measured on a scale far grander than anything we have known. Physicists call this idea the Kardashev scale, a gentle way of categorizing civilizations not by their behavior or appearance, but by the energy they can harness. Energy is a universal language. It shapes planets, fuels stars, and defines what technology can accomplish. And so, this scale imagines 3 broad stages of advancement, each one a milestone in a species' ability to use the power around it. A type just. Civilization has mastered all the energy available on its home planet. It can tap into winds, oceans, sunlight, volcanic heat, and weather patterns with ease. Storms are not feared, they are understood. Natural disasters become controllable. Climate becomes a manageable system, not a force of chaos. Such a society would live in harmony with its world, using its full planetary potential. Humanity, by contrast, has not reached this stage. We still rely heavily on fossil fuels and extractive practices. On this scale, we are labelled Type 0, a species taking its first cautious steps toward planetary maturity. A Type 2 civilization goes further. It harnesses the full energy output of its star. Imagine a species capable of capturing a significant portion of the light and heat from its sun, Perhaps through an immense structure or swarm of satellites that encircle their star, sipping its energy like a flower draws in sunlight. This concept, often called a Dyson sphere or Dyson swarm, is not fantasy but physics. A Type 2 society would have access to power levels millions of times greater than ours, allowing them to reshape their entire solar system if they wished. A Type 3 civilization operates on a scale almost beyond imagination. It harnesses energy from an entire galaxy, controlling the power of billions of stars, manipulating black holes, and perhaps bending space-time itself. Such a civilization would no longer be confined to a single world or even a single star system. It would roam the space lanes between suns, mastering technologies that appear to us like legends: interstellar travel, wormholes, maybe even the creation of new universes. If such beings exist, they could be 100,000 years ahead of us, or more, a span of time so vast that their capabilities might seem indistinguishable from magic. And yet this scale does something beautiful. It reminds us that intelligence is not a fixed point. It grows, it evolves, it adapts. We too are on this journey, slowly learning to use the energy of our planet with more care, more creativity, and more humility. As you breathe softly now, imagine the night sky as a ladder of possibility. Somewhere out there, perhaps a Type Sahon civilization is just beginning to steward its planet. Somewhere else, a Type 2 society orbits calmly around a bright star wrapped in technology. And farther still, maybe a Type 3 civilization drifts through galactic space, their presence subtle, silent, and far beyond our understanding. The Kardashev scale doesn't tell us whether such beings exist. It simply invites us to imagine how intelligence might grow across cosmic time, expanding gently, like light travelling outward from a star. For all our brilliance, our telescopes, our cities of light, our stories whispered across continents, humanity is still a young species. We have mapped the sky, decoded atoms, and peered into the fabric of space-time. Yet in the grand cosmic hierarchy of energy and mastery, we remain at the very beginning. On the Kardashev scale, we are Type 0, a civilization not yet able to harness even the full power of our own planet. It is a humbling thought, but also a comforting one. Being Type 0 does not mean we are primitive, it means we are early. We are living in the dawn of consciousness, the fragile morning of a species learning how to care for the world that cradles it. We draw our energy from dead plants, oil, coal, gas, remnants of life long gone. We still depend on fuels that leave marks on the air and the oceans, fuels that bind us to old limitations. We have not yet learned to gather the full rhythm of the winds, the tides, the heat beneath our feet, or the sunlight that pours down freely every day. And yet, there is beauty in this stage of growth. Humanity is waking up. We are beginning to understand the fragility of our climate, the importance of our ecosystems, the need for balance rather than consumption. Type 0 is not a failure. It is a beginning. The universe gives us time to evolve, if we choose to use it wisely. Physicists often point out that the jump from Type 0 to Type 1 is one of the most challenging transitions any civilization faces. It requires cooperation, stability, and a deep awareness of how precious a planet truly is. A species must learn to protect its home rather than exhaust it. It must shift from extraction to stewardship. It must replace short-term impulses with long-term vision, a vision that sees not just decades ahead, but centuries. Imagine Earth 1,000 years from now, if humanity succeeds. Our cities powered entirely by renewable energy, our atmosphere healed and stable, our technologies harmonizing with nature rather than disrupting it, storms managed, disasters mitigated, ecosystems restored. The planet becomes not a resource to be consumed, but a partner, alive, balanced, and understood. This is the essence of a Type 1 civilization. Not domination, but harmony achieved through knowledge and care. But tonight, as you rest, there is no need to rush forward in your mind. Instead, breathe softly into the understanding that our journey is unfolding at its own pace. We are still learning, still exploring, still adjusting to the responsibility of awareness. And though we are Type 0 now, that classification carries a quiet promise. We have room to grow. We have potential shimmering in every innovation, every act of preservation, every moment of curiosity. As you exhale, imagine humanity standing on the first rung of a cosmic ladder. Above us, countless steps remain unseen. But beneath our feet, the ground is firm. We have begun. And with each discovery, each insight, each shift toward gentler living, we move a little closer to the next stage of our cosmic story. For now, being Type 0 is more than enough. It is the reminder that we are at the beginning of something vast, not behind, not late, simply early in the quiet unfolding of what we may one day become. When we think about the future of humanity, we often picture technologies just a few steps beyond our own. Faster computers, cleaner energy, spacecraft that reach the outer planets. But the universe invites us to stretch our imagination much further. If life began on other worlds long before it began here, then other civilizations may have had tens of thousands, even hundreds of thousands, of years to evolve beyond us, and in cosmic time 100,000 years is only a breath. What would such a civilization look like? What would they understand that we do not? What forces would they command that we still consider impossible? Physicists suggest that to manipulate space-time, open wormholes, or travel between stars with ease, a society would need to control energies close to those found in the hearts of black holes, or the birth of the universe, energies we call the Planck scale, far beyond anything humanity can reach today. If a civilization has mastered that level of power, they would be what we classify as Type 3 on the Kardashev scale. Beings who draw energy from entire galaxies, who navigate among stars the way we navigate rivers, who treat black holes not as mysteries, but as tools. They might bend gravity to shape their pathways. They might slip through space-time rather than travel across it. For them, the speed of light, the great cosmic limit that binds our technology, might simply be another horizon to move beyond. To us, such abilities sound like science fiction. But consider how our own technology would appear to ancient humans. The glow of a smartphone would resemble magic. Airplanes would seem like mythical creatures. Satellites would be stars that move with intention. Even now, a child can access more information in minutes than entire civilizations could gather in centuries. What feels ordinary to us today would feel impossible to those who came before. So imagine for a moment a species 100,000 years more advanced than us. Their understanding of physics would eclipse ours the way a mountain eclipses a pebble. They would move through the galaxy with a level of precision we cannot fathom. Their technologies might not even be physical in the ways we recognize. They could be built from forces rather than materials, from fields rather than metals, from principles we have not yet discovered. And yet, being advanced does not mean being obvious. A Type 3 civilization might be subtle, quiet, and entirely uninterested in broadcasting its presence. Their technology could be indistinguishable from nature, or hidden by design. We may have passed by traces of such beings without realizing it, because recognizing intelligence vastly beyond our own is like an ant trying to recognize the purpose of a cathedral. As you breathe softly now, imagine these ancient civilizations drifting through the galaxy like currents of light. Not threatening, not loud, simply existing on scales so grand that our brief human timeline cannot contain their story. Perhaps they watch stars ignite and fade. Perhaps they guide the flow of cosmic energy. Or perhaps they wander, curious and gentle, exploring the universe with the same wonder that lives quietly within you. If such civilizations exist, They remind us of a simple truth: humanity is still at the beginning. We are not late arrivals. We are early dreamers in a universe filled with possibilities that take time, vast, magnificent time, to unfold. If a civilization reaches the level of mastery imagined in the Kardashev scale's second tier, its presence might not be revealed through messages or spacecraft, but through light. A Type 2 civilization, capable of harvesting the full energy of its star, would reshape the glow of that star in subtle but detectable ways. Its technology might form a vast swarm of collectors orbiting in silence, a structure often called a Dyson sphere, or more realistically a Dyson swarm, countless satellites capturing starlight the way leaves capture sunlight. It is a breathtaking idea that somewhere in the galaxy, a star could be wrapped in a shimmering shell of technology, its light filtered, repurposed, sculpted into power for a distant society. And even though such a structure would be far beyond our current abilities, physics does not forbid it. The concept is not born from fantasy, but from logic, from recognizing that energy is the lifeblood of any advanced civilization. So astronomers search. They look for stars that shine strangely, stars that radiate the wrong kind of light, or less light than they should. A Dyson structure would block some wavelengths and re-emit others in a characteristic pattern. A thermal glow, a signature that is faint but distinct. In essence, we look for stars that seem dimmed or warmed artificially, as though wrapped in a cosmic blanket. Over the past decades, scientists have sifted through vast catalogues of stars, searching for such anomalies. One famous candidate, known as Tabby's star, flickers in irregular ways that puzzled astronomers around the world. At first, some wondered whether it might be explained by alien engineering. Its brightness dipped by unusual amounts. Too sharp for planets, too complex for typical stellar behaviour. But as data accumulated, the evidence pointed toward natural causes: clouds of dust, drifting comets, or processes we still do not fully understand. And yet even natural explanations are beautiful. They remind us that the universe is full of mysteries that mimic the extraordinary. The search for Dyson spheres is not a failure when the answer is dust. It is a triumph of curiosity. For every question we answer, a dozen new ones emerge. More importantly, the search teaches us something deeper. Detection requires sensitivity far beyond what we currently possess. Our telescopes, though powerful, are still young instruments compared to the scale of the galaxy. A Type 2 civilization, even if common, could remain invisible simply because our eyes are not yet sharp enough. The absence of detection is not the absence of presence. It is the silence of tools still learning how to listen. Imagine, then, a future where humanity has advanced to Type 1 or beyond. Our observatories might grow to unimaginable precision. We might map the galaxy with clarity so fine that even a single artificial satellite orbiting a distant star leaves a recognizable trace. One day, perhaps, the glow of a Dyson swarm will stand out unmistakably, the gentle hum of an advanced civilization harvesting its star's gift. As you breathe softly now, imagine drifting past such a star. Its light is warm, controlled, almost sculpted. Around it, thousands of structures orbit with quiet precision, forming a dance older than nations, older than stories. You do not see the beings who built it. You only see the harmony of their design, a whisper of intelligence written in starlight. In searching for Dyson spheres, we are not chasing science fiction. We are learning to recognize the fingerprints of possibility, and in that search, we come a little closer to understanding how vast, how varied, and how wondrous the universe may truly be. For all our searching, for all the planets we've catalogued, all the starlight we've analysed, all the cosmic patterns we've tried to decode, the universe remains overwhelmingly silent. This silence is not empty or cold. It is expansive, ancient, and strangely comforting. Astronomers often call it the Great Silence, a phrase that holds both mystery and meaning. If life could exist elsewhere, why haven't we heard from it? In the quiet of night, when the stars settle softly above you, this question feels less like a puzzle and more like a meditation. Silence is not necessarily absence. It may simply be distance, the kind so vast that signals fade before they reach us. Or it may be timing, civilizations rising and falling across millions of years, their windows of communication never overlapping. The universe is old, unimaginably old. Entire species could bloom like flowers and vanish before light from their worlds ever reaches our telescopes. And of course, there is the humbling truth that our listening tools are still young. We've been sending radio waves into space for just over a century. Our telescopes have scanned only a tiny slice of the sky, at only a few frequencies, for only a blink of cosmic time. Expecting immediate answers is like dipping a single cup into the ocean and wondering why you didn't find a whale. There is also the possibility that advanced civilizations have no interest in broadcasting their existence. On Earth, intelligence does not always shout. Dolphins sing beneath the waves. Owls glide without sound. Some species communicate only through chemicals or vibrations. Perhaps the galaxy is filled with minds who speak in ways we cannot yet detect, in gravitational pulses, subatomic modulations, or fields that our technology has not begun to sense. And if a civilization is far older than we are, its methods of communication may be unrecognizable. A species 100,000 years ahead might not use radio waves at all. They may have moved beyond signals, beyond technology as we understand it. Their presence might blend seamlessly into the fabric of nature, unnoticed unless we learn to see differently. But silence can also be a form of protection. It is possible that intelligent beings understand the dangers of announcing themselves across the cosmos. On Earth, even our own scientists debate whether broadcasting our presence is wise. The night sky may be serene, but we cannot assume every corner of the universe is gentle. Perhaps the galaxy's quiet is a sign of collective caution, civilizations choosing safety over contact, remaining watchful, hidden, thoughtful. As you breathe softly, imagine the silence not as emptiness, but as a vast open canvas. Within it lie possibilities, some hopeful, some sobering, all profound. The great silence invites us to listen with patience rather than urgency. It suggests that just because we have not heard a voice does not mean none exist. It reminds us that silence can hold secrets, waiting for the right moment, the right tools, the right alignment of time. One day, the silence may break, or perhaps we will learn to interpret its patterns, discovering that the universe has been speaking in ways we overlooked. Until then, the quiet around us offers a gentle space to wonder, a soft reminder that mystery itself can be a source of peace. When we listen for life beyond Earth, we do something profoundly human. We turn our attention toward the sky and wait. Not with expectation, not with impatience, but with a quiet openness. The same kind of listening you might use when sitting beside a forest at dusk, letting the sounds of wind and distant birds drift into your awareness. The universe speaks softly, and learning to hear it requires stillness. Radio telescopes, scattered across mountaintops and desert plains, rotate slowly through the night, gathering faint signals from across the cosmos. These signals tumble through space for centuries, sometimes millennia, before touching the metal surfaces of our instruments. Most of what they carry is nothing more than natural noise, the gentle static of stars burning, the hum of cosmic background radiation, the crackle of charged particles spiraling around magnetic fields. Yet within this noise lies the possibility of something more. Scientists have spent decades tuning into this cosmic static, sorting random fluctuations from structured patterns. They look for signals that stand out, pulses that repeat with unusual precision, frequencies that nature rarely produces on its own, sudden bursts that seem intentional rather than accidental. The task is delicate, almost meditative. It requires patience, skepticism, and wonder in equal measure. Sometimes the sky surprises us. A peculiar signal arrives, shimmering with regularity, and for a moment the world holds its breath. But most of these moments fade into explanations, interference from Earth, reflections from satellites, emissions from distant stars. Each explanation is a reminder that the universe is full of activity, alive with processes we are still learning to understand. But even when a signal turns out to be natural, the search is never a disappointment. Listening itself is valuable. It expands our awareness of the cosmos and deepens our appreciation for the intricate symphony of energy that surrounds us. Every new observation teaches us more about how stars behave, how galaxies evolve, how the fabric of space carries whispers of its own origins, and on rare occasions, something emerges that science cannot immediately explain. A brief flare of order, a narrow band emission, a repeating pattern that refuses to settle into randomness. These anomalies invite deeper investigation, reminding us that even with all we know, the universe retains its ability to surprise. They keep curiosity alive. Imagine now standing beside one of these great radio dishes as it scans the sky. The night is quiet. The metal frame hums softly. Above you, stars drift across the darkness like silver seeds, floating in an infinite orchard. Somewhere among them, perhaps on a distant world, something might be speaking, not with words but with rhythm, energy, or structure. The telescope listens, and in its listening it transforms the sky into a conversation. As you breathe deeply, feel the stillness within yourself echo the stillness of the night sky. Listening, after all, is not only about sound, it is about attention, the gentle act of opening to what might be there, or what might arrive. We do not know if anyone is speaking to us, but we do know how to listen. And in that simple act, humanity connects with the universe in a way that transcends distance, time, and silence. The universe often speaks in whispers. A faint pulse here, a soft rhythm there, a narrow beam of energy that dances briefly across our detectors before dissolving into the background. When these signals appear, sudden, crisp, almost intentional, they spark something deep within us, a quiet thrill, a pause, a sense that perhaps for the briefest moment, another mind has brushed against ours across the gulf of space. But most of these whispers are not messages. They are natural phenomena wearing the disguise of order. Pulsars, rapidly spinning stars, emit regular pulses that once convinced astronomers we had found extraterrestrial beacons. Quasars blaze with energy so intense it once seemed artificial. Even everyday terrestrial interference, a passing satellite, an airplane, a distant electronics glitch, can paint the illusion of communication. The universe is filled with activity, and nature often crafts patterns convincing enough to make us wonder. In this way, the search for life becomes a dance between hope and skepticism. Scientists are trained to question, to test, to peel away layers of coincidence until only truth remains, and yet they must also remain open, ready to recognize something genuinely unusual when it arrives. Striking that balance is not easy. A single line of data can feel like a heartbeat in the dark, but it can also be a mirage produced by the cosmos itself. One of the most famous signals, known as the wow signal, lasted just 72 seconds. It was loud, narrow, and strangely precise, the kind of signal no natural object should produce. To this day, its origin remains uncertain. Was it a brief cosmic coincidence, a passing object reflecting radio waves? Or was it something more deliberate, more distant, more wondrous? We may never know. The ski kept it secret. False alarms are not failures. They are part of the story, part of the process of learning to listen. They reveal how easily our expectations can be stirred and how complex the universe truly is. They remind us that discovery is not a straight path but a winding trail through layers of noise and meaning. Each unusual signal, whether explained or mysterious, teaches us something about stars, about physics, about the fine art of patience. As you breathe gently now, imagine yourself leaning over an ancient radio, turning the dial slowly through static. Here and there, faint patterns emerge, fragments of melody, clicks of rhythm, almost words dissolving before they take shape. For a moment you wonder if someone is trying to speak. Then the sound fades, becoming part of the static again. The mystery remains, soft and unresolved. This experience mirrors the cosmos. We listen, we interpret, we hope. Sometimes the whispers are illusions, sometimes they are puzzles waiting to be solved, and sometimes, perhaps, they are genuine hints of something beyond our understanding, too brief, too faint, too unusual to classify with confidence. But in each case, the process brings us closer to the truth. It teaches us to refine our instruments, sharpen our minds, and deepen our curiosity. False alarms are not dead ends. They are stepping stones, guiding us toward a universe that reveals itself slowly, deliberately, with a kind of cosmic shyness. Tonight, let the whispers of the universe settle around you like soft static. Let them remind you that uncertainty is part of wonder, and that every question, even one that leads to a false alarm, keeps us listening. For most of human history, stories of strange objects in the sky lived on the edge of belief, spoken in quiet conversations written in the margins of journals, whispered by travellers who saw something they could not explain. But these stories rarely carried weight in the scientific world. They lacked consistency, evidence, and repeatability. They were fragments, too soft to build understanding upon. Then, slowly, something changed. Not in the sky, but in the way we record it. In the last few decades, military aircraft, naval vessels, and advanced tracking systems have begun capturing high-resolution data of unusual aerial objects, data far more precise than anything available before. Suddenly, these sightings were no longer just anecdotes. They were measurements. They were numbers. They were time-stamped, multi-sensor recordings that could be analysed frame by frame. For the first time, physicists and engineers could examine phenomena not as blurry lights, but as objects with detectable acceleration, trajectory, and velocity. Some moved in ways that challenge our understanding of physics, accelerating from zero to extreme speeds in an instant, performing sharp turns that would crush any known airframe, crossing from air to water without slowing, travelling at velocities that exceed what our materials can withstand. The data itself remained calm, simple coordinates, vectors, temperature profiles, but the implications whispered something astonishing. These craft, whatever they are, do not behave like anything we have built. And the most remarkable shift was not in the sky, but on the ground. Authorities who once dismissed such sightings with silence or ridicule began to acknowledge them openly. The US Navy confirmed the authenticity of several videos. Pilots came forward not just with stories but with cockpit footage and radar logs. Scientists were invited to examine the recordings, breaking a long history of reluctance and secrecy. Suddenly, encounters that would once have been ignored or buried were being discussed in congressional hearings, technical reports, and scientific journals. This change did not happen overnight. It came from public pressure, investigative journalism, and the legal force of freedom of information requests. Each wave of inquiry pulled back another layer of secrecy until the military could no longer deny what it possessed. A gold mine of data waiting to be understood. And so, the burden of proof quietly shifted. Instead of demanding that witnesses justify their claims, the scientific community now asks the military to justify its conclusions. The question is no longer, are these objects real? But what are they, and why do they move this way? As you breathe softly now, imagine radar screens glowing in dim control rooms, recording objects that appear and vanish in the blink of an eye. Imagine pilots seeing something impossible cut across the horizon. Imagine analysts leaning close to their screens, looking for patterns, for clues, for meaning in the trails of numbers scrolling past. We still do not know what these objects are, but for the first time we have data solid enough to study, question and explore. The sky is no longer a place of unfounded stories, it is a canvas of measurable mysteries. And in each new recording, the universe seems to lean just a little closer, inviting us to understand the unknown with open eyes and a quiet, steady curiosity. When we look at the sky through the lens of modern instruments, we expect to find familiar patterns. Aircraft shaped by aerodynamics, meteors following graceful arcs, satellites tracing predictable paths. But some of the objects captured in recent years move with a kind of quiet defiance, as if they are following rules we have not yet learned. They accelerate without sound, turn without inertia, and shift between air, water and space with no visible transitions. These behaviours don't just challenge our technology, they challenge our understanding of physics itself. In cockpit videos, a tiny white shape zips across the screen, shifting direction so abruptly that any being inside would be crushed. Pilots speak in calm but bewildered voices, describing movements no known craft should be able to perform. Instant acceleration from Mach 5 to Mach 20, sharp zigzags that generate forces far beyond the limits of human endurance. Radar systems track these objects diving into the ocean without slowing down, disappearing beneath the waves as though water were no more resistant than air. Such capabilities would require engineering beyond anything we can build. Our aircraft rely on wings, turbines and fuel. They must negotiate drag, heat and G-forces. But these objects appear unconstrained by such limitations. They leave no sonic booms, no exhaust trails, no turbulence. Their motion seems to ignore friction and inertia, behaving more like ideas than machines, a kind of kinetic poetry carved into the sky. Scientists examine the data with a careful blend of skepticism and wonder. Could these be artifacts of instrumentation, atmospheric illusions, misinterpretations of distance or speed? Many sightings fall into these categories. Most, in fact, can be explained through natural or technical means, but a small fraction, the ones with multiple forms of confirmation, where radar, infrared sensors, and visual observations all align, resist simple explanation. They invite us to consider the possibility that nature still holds secrets we have not unlocked, or that technology far ahead of our own has brushed against our reality. The implications are profound. If such craft are human-made, then someone on Earth has achieved a revolution in engineering so far beyond our public knowledge that it borders on the impossible. If they are not human-made, then we must consider something even more humbling. A civilization capable of manipulating forces we barely understand, perhaps drawing energy not from combustion, but from principles woven deep into the structure of space-time. As you breathe softly now, imagine watching one of these objects move across a dark horizon. It glides with effortless precision, changing direction like a thought. It rises, falls and vanishes with no hint of strain. There is no roar, no blaze, no trail, only silence. A silence so complete it feels intentional, as though the craft itself respects the quiet of the night. Whether these objects belong to nature, to humanity, or to something beyond, they remind us that the universe is not finished teaching us how motion works. There are still patterns we have not deciphered, forces we have not learned to guide, and possibilities that lie just beyond the edge of our understanding. In their graceful strangeness, these machines, whatever they are, whisper a gentle truth. The universe is larger, stranger, and more wondrous than our current imagination allows. And perhaps, somewhere in that mystery, lies the next step in our journey toward deeper understanding. In the vast ledger of unexplained aerial phenomena, most entries eventually settle into familiar categories. A strange light becomes a weather balloon. An erratic blip on radar turns out to be a bird or atmospheric reflection. A shimmering object on the horizon becomes a distant aircraft seen at a rare angle. Roughly 90% of sightings find their place within the boundaries of known science, known technology, or known illusion. And this is reassuring. It means our understanding of nature is strong, that the sky behaves mostly as we expect. But then there is the 10%. A small, stubborn fraction of sightings defies easy classification. These events linger in the mind not because they are dramatic, but because they are precise. They involve trained observers, multiple detection systems, and consistent behavior across instruments. They do not wobble with uncertainty. They stand firm, like quiet fingerprints left on the window of our understanding, refusing to be smudged away. In these cases, the data remains clear even when the explanation does not. Objects accelerating faster than our materials should allow, shapes with no visible propulsion, craft that transition from air to water without slowing, as though the boundaries between states of matter are optional. Movements that ignore momentum, turning sharply in ways that would turn any passenger into vapor. Scientists studying the numbers sometimes find themselves staring not at possibilities, but at contradictions, the universe behaving in ways our current equations do not permit. This 10% does not prove extraterrestrial life. It does not prove hidden technology or secret breakthroughs. But it does prove something equally important, that there are phenomena in our skies operating outside the limits of our present understanding. They are reminders that science is not finished, that nature is still writing chapters we have not yet read. What makes these sightings particularly compelling is not just the behavior, but the convergence of evidence. An anomaly seen by a single witness can be dismissed. One captured on video can be questioned. But when pilots, radar systems, infrared cameras, and tracking stations all record the same object performing the same impossible maneuvers, skepticism shifts. We no longer ask, did something happen? But what was it? As you breathe softly now, imagine sitting in the cockpit of a jet, watching a small dot flit across your display faster than anything you've ever seen. Imagine the radar confirming what your eyes perceive. Imagine your instruments insisting that the object has just performed a maneuver no aircraft should survive. There is no fear, only wonder, only the realization that the sky is not fully mapped. The 90% anchors us. It tells us the world is knowable, predictable, rational, but the 10% keeps us humble. It shows us that even with all our science, all our senses, and all our certainty, the universe still reserves a corner of itself for mystery. And perhaps that is how it should be. Without the 10%, curiosity would fade, discovery would stall, and the night sky would lose a little of its magic. But because of it, we keep listening, we keep searching, we keep wondering whether those anomalies are not random at all, but the faint stirrings of a larger truth waiting patiently beneath the stars. In science, extraordinary claims require extraordinary evidence, and when it comes to unidentified aerial phenomena, the most extraordinary evidence comes not from blurry videos or uncertain glimpses, but from the rare moments when multiple independent systems witness the same event in harmony. These are the sightings that scientists call the gold standard, cases where radar, infrared sensors, cockpit cameras, and human eyes all converge on a single undeniable truth. Something was there. Such convergence is powerful. Radar sees through clouds and darkness. Infrared detects heat signatures invisible to ordinary cameras. Pilots perceive motion, speed, and physical presence in ways machines cannot fully replicate. When all these perspectives align, the probability of misinterpretation shrinks. Nature may play tricks on us one at a time, but it rarely deceives multiple instruments simultaneously. Imagine an object darting across the ocean surface. A pilot sees it, a pale shape against the water. At that same moment, the ship's radar captures it, tracking its movement with mathematical precision. An infrared camera records its heat profile, showing no exhaust, no thermal plume. Together, these three strands of evidence weave a tapestry too consistent to dismiss. It is no longer merely a sighting, it is a measurement. These events do not come often, but when they do, they spark deep curiosity. One such encounter can generate thousands of pages of reports, diagrams, and sensor logs. Engineers pore over acceleration curves. Physicists analyze motion that seems to defy inertia. Aviation experts recheck readings, searching for the familiar within the impossible. Even skeptics pause, acknowledging that while nature holds many tricks, few explain the complete picture. What makes these gold standard cases so striking is not just the technology involved, but the calm, methodical way they unfold. The pilots are not frightened. They are trained observers, accustomed to high-speed maneuvers and unexpected situations. When they describe something unusual, they do so with precision. Altitude changes, vector shifts, rate of descent. Their voices remain steady, almost serene, even when witnessing objects that accelerate faster than anything known to human engineering. And yet, even with this convergence of data, certainty remains elusive. The objects refuse to reveal their nature. They leave no wreckage, no debris, no obvious signatures of propulsion. They appear briefly and vanish just as quickly, like ripples on the surface of a vast dark ocean. The gold standard does not give us answers. It gives us clarity that a genuine mystery exists. As you breathe softly now, imagine standing in a control room, illuminated by the gentle glow of screens. Dots glide across radar displays. Cameras capture faint shapes against the night. Operators speak quietly, confirming readings, aligning perspectives, ensuring that what they are seeing is real. There is no drama, no panic, only the steady rhythm of observation, the calm heartbeat of scientific curiosity. In these rare moments, the universe pulls back the curtain just a little, revealing hints of something we do not yet understand. The gold standard tells us not what these objects are, but what they are not. Illusions, misreadings, or simple mistakes. They occupy a space between the known and the unknown, urging us to look deeper, to study more carefully, and to remain open to the possibility that our understanding of the sky is still incomplete. In this quiet convergence of instruments and human perception, we find not fear but wonder, a reminder that the universe is still full of unsolved pages, waiting patiently for us to read them. Among the rare cases that meet the gold standard of evidence, the one stands out like a quiet beacon in the long history of mysterious sightings. The 1986 encounter of Japan Airlines Flight 1628 over Alaska. It is not a legend whispered in conspiracies, nor a blurry tale lost in translation. It is a documented event witnessed by experienced pilots, confirmed by radar, and recorded in official logs. And it unfolded not in chaos or fear, but in calm professionalism, the kind that holds even more weight than excitement ever could. Picture the scene, a cargo flight heavy with wine from Paris, cruising peacefully over the frozen expanse of Alaska. The sky is dark, clear, serene. Below, the vast white of the earth stretches endlessly. Above, the stars shine with a steady glow. Inside the cockpit, 3 pilots go about their routine tasks, lulled by the rhythm of long-distance flight. Then, quietly, something appears. Far off the wing, 2 objects gliding with graceful precision. They move not like airplanes, not like meteors, but like something aware of its own presence, rotating, shimmering, shifting slightly as if adjusting to the aircraft's motion. The pilots watch, stunned but composed. They report the objects to air traffic control, their voices steady, almost clinical. These are trained observers, professionals who do not leap to conclusions, and then the instruments respond. Military radar picks up the objects. Civilian radar confirms them. Multiple systems, independent yet aligned, record their position. For several minutes, the two objects pace the flight, maintaining distance but remaining unmistakably present. The pilots describe their lights as bright and structured, unlike any known aircraft patterns. Then, as quietly as they arrived, the two objects drift away. But the encounter is not over. Moments later, a third object appears, massive, silent, and far larger than the first two. Its size is so immense that when the flight crew looks toward it, they say it feels like an entire moving city, blocking out a portion of the sky. The captain later described it as a giant silent ship, something far beyond any aircraft he had ever known. The crew feels no threat, only awe. They request a course change, and air traffic control, now aware that they are not imagining things, approves it. The object follows for several minutes more, then slowly fades into the darkness, leaving the pilots with a calm but heavy silence. After the plane lands, the pilots report exactly what they saw. They do not dramatize, they do not speculate, they simply describe the shapes, the lights, the proximity, and the duration. But instead of being celebrated for their clarity, they are quietly removed from flight duty, reassigned to desk positions as though their honesty were a liability. The message, whispered institutionally, was clear. Do not speak of what you saw. This reaction had a chilling effect across the aviation community. Pilots, fearing demotion or ridicule, kept silent about unusual sightings for decades. Data that could have enriched science stayed locked in logbooks or in memory alone. As you breathe softly now, imagine what it must have felt like. The cockpit dimly lit, the hum of instruments steady, the Arctic wilderness stretching in all directions, and outside the window something vast and unknown drifting alongside you. Neither hostile nor friendly, simply there. The JAL 16-28 encounter does not give us answers, but it reminds us how much the sky still holds, how many stories remain untold, and how many clues sit quietly in the spaces where courage meets curiosity. In science, progress depends not only on the data we gather, but on the honesty with which we share it. And yet, for many years, the skies were filled with unspoken stories, encounters witnessed by the most skilled observers on Earth, pilots who watched the horizon for a living, who understood the difference between a reflection, a weather pattern, and something truly out of place. These pilots saw strange objects move with impossible precision, but instead of being encouraged to report their experiences, they learned to keep quiet. The silence did not come from fear of the unknown. It came from fear of consequence. After the JAL 16-28 incident, when seasoned pilots were removed from flight duty for reporting what they saw, a chill settled over the aviation world. The message spread quietly, without official statement or written rule. If you speak about what you saw, you risk your career. And so an unspoken agreement formed, fragile but powerful. Pilots would observe, but not report. They would wonder, but not record. They would remember, but not share. This loss cannot be measured easily, but it is enormous. Imagine how many sightings went unlogged, how many radar anomalies were dismissed, how many unusual encounters dissolved into the silence of unspoken memories. For decades, the world's most trained eyewitnesses became reluctant custodians of experiences they could not discuss. The sky kept offering mysteries, but the people best positioned to describe them were discouraged from doing so. Silence became a filter, one that allowed only the mundane to pass through, while the extraordinary remained hidden behind personal caution. Researchers studying unidentified aerial phenomena struggled not because there was nothing to investigate, but because the most credible data never reached them. In science, missing information is not neutral. It shapes the narrative of what we believe to be true. And this silence had another effect, one even more subtle. It shaped our collective imagination. Without consistent reports, unusual sightings became fodder for fringe speculation rather than legitimate scientific inquiry. The extraordinary was pushed to the margins, not because it lacked evidence, but because the evidence was quietly discouraged from existing. But silence is not permanent. Over time, pressure from civilians, journalists, and persistent researchers began to challenge this culture of withholding. The world changed. Cameras became ubiquitous. Freedom of information laws opened doors once locked. Military and government agencies faced growing demands for transparency. And as the walls shifted, data long hidden began to surface. Radar logs, infrared recordings, cockpit audio, and testimonies previously sealed away. Yet even now, as you breathe quietly into the present moment, you can feel the weight of that past silence. It reminds us that the search for truth is not only a scientific challenge, but a cultural one. For the universe does not hide its mysteries out of malice. It reveals them freely. It is we, as a species, who choose whether to acknowledge or ignore them. As you rest into this thought, imagine all those unspoken stories floating above us, like invisible constellations waiting for someone to trace their shape. The sky has always been generous with its secrets. It was our fear, not the stars themselves, that kept those secrets quiet. For a long time, the sky kept its mysteries not because the universe was withholding them, but because institutions were. Behind closed doors sat hours of footage, stacks of radar logs, and testimonies sealed away in classified archives. Scientists knew the data existed, but they could not reach it. Civilians suspected there was more to the story, but they could not prove it. It was as though the truth about the sky lived behind a veil that no one was allowed to lift. Then, slowly, the veil began to thin. Not through secrecy, but through the quiet persistence of people who believed that knowledge belongs to everyone. Journalists filed requests. Citizens demanded answers. Advocates pushed for transparency. And through the power of the Freedom of Information Act, long silent archives began to open. What once was hidden became accessible piece by piece, like starlight emerging as clouds drift away. Suddenly, data that had been locked in government vaults was released into public view. Radar recordings documenting impossible maneuvers, infrared videos showing objects without heat signatures. Testimony from military pilots who had watched strange craft move with precision beyond any known aircraft. These pieces of information had existed for years, sometimes decades, but were shielded by layers of classification that kept them out of the scientific conversation. With FOIA requests, the balance shifted. The burden of proof no longer rested on witnesses trying to convince authorities that they had seen something unusual. Instead, the responsibility shifted upward. Governments now had to explain why these objects did not match any known technology or natural phenomenon. This reversal marked a quiet turning point. Not dramatic, not loud, but profoundly important. As documents and recordings surfaced, researchers finally gained the raw material they needed to study these anomalies seriously. Patterns could be analysed. Flight paths could be reconstructed. Behaviours could be measured with mathematical clarity. The conversation reframed itself from "did something happen?" to "what is the nature of what happened?" And with each release, the scientific community moved one notch closer to treating unidentified phenomena not as taboo, but as genuine data worthy of rigorous investigation. Yet the FOIA shift also revealed something deeper, that secrecy can delay discovery just as effectively as ignorance. Imagine how far our understanding of the skies might have progressed if these recordings had been openly shared from the beginning. How many insights were lost because the people who needed the data could not access it? How much earlier might the world have recognized that some objects behave in ways outside our established frameworks? As you breathe gently now, imagine standing in a quiet archive room as old film reels and digital logs are brought out from shadow into light. Dust lifts from the shelves, screens flicker with images that once lived behind locked doors. The past feels nearer, clearer, no longer muffled by silence. It is not that the universe has changed, it is that we have finally chosen to look with open eyes. The foyer shift reminds us that transparency is not merely a political ideal, it is a scientific necessity. Knowledge flows best when barriers are removed, and when curiosity is allowed to move freely. For in that flow, truths long hidden begin to surface, and the universe, patiently waiting, reveals just a little more of itself. For decades, whenever someone reported seeing something strange in the sky, the world responded with a familiar script: disbelief first, dismissal second. The burden of proof rested entirely on the witness, on the pilot who risked ridicule, on the radar operator who feared professional reprimand, on the scientist who hesitated to speak outside strict boundaries of accepted explanation. To say, "I saw something," was to take a step into uncertainty, not because the sky was unclear, but because the culture around it demanded certainty before curiosity. But slowly, quietly, the ground shifted. As declassified documents emerged, as military videos were released, as radar logs confirmed what eyes had already seen, the narrative began to tilt. People no longer came forward with only stories, they came forward with data, with measurements, with synchronized recordings from multiple systems, and with this evidence, the old dynamic began to dissolve. No longer could unidentified objects be dismissed as illusions, misinterpretations, or tricks of light. The sky was telling its story in verifiable detail, and then, almost without fanfare, a new truth settled in. The burden of proof no longer falls on the witnesses, it now falls on the institutions. Governments, militaries, and scientific authorities must now demonstrate that these objects are not extraordinary, rather than forcing observers to prove that they are. The responsibility has inverted, like a mirror turning to face a different horizon. This shift is subtle but profound. It represents a cultural acknowledgement that some phenomena cannot yet be explained by conventional means, not because they are impossible, but because our understanding is incomplete. It recognizes that data, not prejudice, must guide inquiry. And it marks a rare moment when skepticism matures into genuine open-mindedness. Imagine for a moment standing at a podium in a quiet briefing room. A video plays on the screen behind you, a grainy infrared recording of a small, bright object accelerating faster than any known aircraft. Journalists ask, "What is it?" And instead of dismissing the question, officials respond, "We do not know," not with fear, not with denial, but with honesty. That honesty becomes the new foundation. Scientists step forward not to debunk, but to analyze, to examine trajectory data, infrared signatures, radar profiles. Engineers inspect flight dynamics that seem to disregard inertia. Mathematicians model acceleration curves that defy established physics. Subject once relegated to the fringes moves gently toward legitimacy, carried not by speculation, but by evidence. As you breathe softly now, imagine the weight lifting from the shoulders of those who once stayed silent. Pilots no longer fear career-ending consequences. Researchers no longer fear academic stigma. The sky feels open again, a domain of wonder rather than ridicule. Curiosity, once constrained by caution, begins to stretch its limbs. The reversal of the burden of proof does not give us answers, but it gives us something equally important: permission to question, permission to look at data without bias, permission to treat the unknown not as a threat, but as an opportunity. It invites us to approach the universe with the humility it deserves, not assuming we already understand everything it contains, but acknowledging how much remains beyond the edges of our knowledge. And in that humility, the sky becomes expansive once more, inviting us to continue listening, watching, wondering. Even as our tools improve and the flow of data becomes clearer, the universe still keeps most of its secrets wrapped in quiet shadow. For every object we track on radar, there are countless more that pass unnoticed. For every signal we detect, there are frequencies we cannot hear. For every theory we test, there are realms of physics still waiting beyond the reach of our equations. It is easy to forget how limited our vision truly is, how much of the cosmos operates outside the narrow window through which we observe. Human senses evolved for a specific world. The softness of air, the warmth of sunlight, the slow rhythms of Earth. But space is not bound by those rhythms. It vibrates with energies we cannot feel, fields we cannot touch, wavelengths we cannot see, and so the universe remains mostly invisible to us. Not because it hides, but because our biology was shaped for life on a small blue planet, not for understanding the vastness beyond it. Our instruments stretch that vision, but even they have boundaries. Telescopes reveal only certain bands of light. Radar sees only certain shapes. Cameras capture only certain forms. But reality is not restricted to these bands or shapes or forms. What we observe is only the surface of a much deeper ocean, its currents flowing in dimensions our senses cannot perceive. Scientists often remind us that the electromagnetic spectrum, all the light the universe emits, spans a range so vast that the tiny portion we can see is like a single note in a symphony. Imagine trying to understand a full piece of music while hearing only one tone. That is how we approach the cosmos, listening to a fraction of its melody, yet trying to infer the beauty of the whole. If intelligent life exists elsewhere, its presence may lie in the parts of the spectrum we rarely explore. It may communicate in ways our instruments do not yet detect. Gravitational pulses, quantum fluctuations, exotic particles drifting between stars. Or perhaps it does not communicate at all, not in any way we would recognize. Intelligence does not have to resemble us. It does not have to reach out. It may simply exist. Then there are the mysteries closer to home. Phenomena caught on sophisticated sensors yet still defying explanation. These objects do not behave the way our aircraft behave. They do not reflect heat the way our engines reflect heat. They do not bend under inertia the way our machines must bend. They slip through domains we struggle to map, moving with a kind of grace that feels foreign and familiar all at once. And still, most of the time, we do not see them coming. Our awareness arrives only after they pass through the narrow beam of our detection. As you breathe softly now, imagine the vastness above you as a canvas painted mostly in invisible colours. Imagine that the stars, planets, and unknown travellers drift through both the visible and the hidden, leaving traces not in photographs but in fields we have not yet learned to read. There is no frustration in this, only wonder. For the unseen is not a failure of perception, it is an invitation to widen our senses, to develop better instruments, to expand our imagination. The universe is not obligated to reveal its full story all at once. It gives us pieces gently as we become ready to understand them. When we search for life beyond Earth, we often imagine something that resembles the living world we know, cells dividing, creatures breathing, forests growing beneath alien skies. But the universe is not limited by our imagination. It does not owe us familiarity. And so, before we can truly understand whether we are alone, we must pause and ask a deeper, quieter question. What counts as life? On our planet, life feels intuitive. We recognize it instantly. The flutter of wings, the movement of water through a leaf, the warmth of an animal's breath. But even here, at home, life dissolves into mystery the closer we look. A virus hovers on the edge of definition, not quite alive, not quite inert. Bacteria thrive in boiling vents where sunlight never reaches. Fungi communicate through vast underground networks that mimic neural pathways. Life, even on Earth, refuses to fit neatly into a single description. So what happens when we extend that question to the cosmos? The universe may host forms of life that bear no resemblance to ours. Creatures made of silicon instead of carbon. Organisms that thrive in ammonia seas. Entities that exist not in solid bodies, but as electromagnetic patterns drifting through the upper layers of a gas giant. Beings for whom time moves differently, whose senses reach beyond light or sound. Life might not require limbs or lungs. It might not require water. It might not require anything we would recognize as a body. And then there is the possibility that life evolves into intelligence beyond biology. Civilizations that shed their physical forms entirely, becoming networks of consciousness woven through machines or fields. A species that masters energy at a type 2 or type 3 level might not need cells at all. It might exist as information, as patterns, as something closer to the memory of a star than to the animals we know. When astronomers search for life, they must therefore search not for shapes, but for behaviour, for signs of complexity rising from chaos, chemical imbalances, repeating structures, patterns that do not appear by accident. Even intelligence, in its simplest form, can be detected through regularity. Just as computers uncover the hidden linguistic patterns in dolphin speech, they may one day reveal signals woven through cosmic noise, signals we once ignored because they did not sound human. And yet the question, what counts as life, also touches something tender within us. It invites us to reflect on why we seek life in the first place. Are we lonely, curious, hoping to feel part of something larger? Or are we searching for a connection that affirms a quiet truth, that the universe is not indifferent, but blossoming with possibility? As you breathe gently now, imagine standing beneath a night sky shimmering with distant suns. Somewhere, perhaps, life stirs in forms unimaginable. Perhaps it moves through oceans of methane. Perhaps it flickers through magnetic storms. Perhaps it drifts as a cloud of charged particles thinking slowly across centuries. All of it, every variation, belongs to the same cosmic story. Life is not defined by shape, or breath, or even biology. Life is the universe learning to organize itself, to sense itself, to reflect on its own existence through countless expressions. And in that light, the question of whether we are alone becomes less about rarity and more about recognizing the many ways the cosmos may already be awake. There is a gentle idea, one that drifts through both philosophy and science, that life is not merely something in the universe, but something the universe does. That every living thing, from the simplest microbe to the most complex mind, is a way for the cosmos to look inward, to reflect upon itself, to witness its own unfolding. And when we ask whether we are alone, we are really asking whether the universe has awakened in other places as well. Consider what it means that you are here, breathing quietly, listening to this story. Your thoughts, your memories, your awareness, all of it arises from atoms forged in ancient stars. Every neuron firing in your mind is built from elements older than Earth itself. In you, the universe has learned to remember. In you, it has learned to wonder. And if that is true here, why not elsewhere? Perhaps on a distant world, under a sun we will never feel on our skin, another being sits in silence, contemplating the same questions. Not in human words, not in human emotions, but in its own language of thought, its own quiet way of perceiving the vastness around it. Perhaps it wonders whether consciousness blooms in other corners of the galaxy. Perhaps it senses that it too is made of stardust. We often imagine alien intelligence as something foreign, even threatening. But intelligence, in its most fundamental form, is simply the universe becoming aware, It is the cosmos folding in on itself, examining its own possibilities through different lenses. You are one such lens. Maybe there are others. The thought is not frightening, it is tender. Imagine a civilization 1,000 years ahead of us, or 100,000. Their technology may bend space-time, their energy may come from stars themselves, but their consciousness, the part of them that wondered, may not be so different from ours. They may gaze at their sky with the same quiet awe. They may feel the same pull toward understanding something immense and beautiful, or imagine a civilization far behind us, taking its first steps toward awareness. Creatures just beginning to question the lights in their sky, life emerging from oceans or deserts or frozen plains, minds awakening slowly, sensing the first stirrings of thought. They too would be reflections of the universe learning to perceive itself. What if consciousness is not a rare accident, but a natural stage of cosmic evolution? What if the universe creates life the way stars create light, not intentionally, but inevitably? In that case, when you look up at the night sky, you are not just seeing distant suns. You are seeing countless opportunities for awareness, each one a potential mirror. As you breathe softly now, imagine the cosmos not as something separate from you, but as something flowing through you. Your mind is a continuation of the stars, a way for the universe to think gently about itself. You are part of its memory, part of its unfolding, part of its endless curiosity. If other beings exist, they too are the universe looking back, and in that shared reflection, across unimaginable distances, we are already connected even if we never meet. There is a kind of loneliness that does not come from being without people, but from standing beneath the night sky and realizing how endlessly the universe stretches beyond our reach. It is a quiet, reflective feeling, not sharp, not painful, but soft, like the dim glow that lingers after a candle is blown out. When we ask whether we are alone in the universe, we are also tracing the outline of this feeling, trying to understand why something so vast can stir something so intimate within us. On Earth, loneliness is a deeply human emotion. It reminds us that we are built for connection, that something in us seeks companionship, not only in others, but in purpose, in meaning, in understanding. Yet cosmic loneliness is different. It arrives not from absence, but from awe. It rises when we consider the distances between stars, the slow drift of galaxies, the silence that fills the space between worlds. It comes when we realize that even if the universe is full of life, the gap between us may be so great that we will never touch, never speak, never cross paths. And still, this loneliness is strangely beautiful. It is the kind of feeling that only beings capable of wonder can experience. A stone does not feel lonely beneath the stars. A river is not troubled by the emptiness beyond the sky. Loneliness, in its cosmic form, is evidence of awareness. It is the universe noticing its own vastness through the lens of your mind. It means that you are capable of imagining more than what you see, capable of yearning for meaning beyond the horizon of your own experience. Consider a moment from your past, a time when you felt small perhaps, but in a way that felt gentle rather than overwhelming. Maybe you stood at the edge of an ocean. Maybe you walked alone through a quiet city at night. Maybe you lay awake, listening to your breath, sensing the distance between yourself and everything else. Those moments were not empty. They were spacious. They opened something within you. Cosmic loneliness feels the same. It invites you to sit with the unknown, not as a threat, but as a companion in your wandering. It tells you that your curiosity is valid, that the questions you hold are shared by countless people across time, and perhaps, just perhaps, they are shared by minds on distant worlds as well. Because if we feel loneliness when we look at the sky, then it is reasonable to think that somewhere else, someone might feel it too. Maybe another species stares upward, longing for connection across the cosmic sea. Maybe they wonder whether intelligence blooms elsewhere. Maybe they feel the same mixture of hope and uncertainty. In that sense, loneliness becomes a thread, delicate, invisible, that connects all conscious beings, even if they never meet. It becomes a universal emotion, woven into the fabric of awareness itself. As you breathe gently now, imagine that loneliness softening, spreading out into spaciousness. The night around you is not empty, it is open. You're not small, you're part of something vast. And the feeling you carry in this moment, this quiet ache for connection, may be shared across worlds, carried by minds you will never see, reflecting the same stars you gaze upon now. Loneliness, in its cosmic form, is not a void. It is a signal, a gentle reminder that you're alive, aware, and part of the universe's unfolding story. Sometimes, when we look at the night sky, we don't just wonder about planets or chemistry or distant suns. We wonder about minds, not bodies, not biology, but the quiet interior worlds that might exist somewhere beyond our own, the thoughts drifting through alien consciousness. The way another species might feel time or memory or longing. This is the dream of other minds, the soft hope that intelligence is not unique to us, but a shared phenomenon written gently into the universe. Imagine, for a moment, a being beneath a different sky, one with 2 moons or a ringed horizon, or storms that shimmer with colours we do not have names for. This being, shaped by a different gravity and a different chemistry, pauses to contemplate the stars above. It wonders whether something else exists out there, whether anyone is looking back, whether separation is the rule of the cosmos or just a temporary stage in its evolution. Their wonder might not sound like ours. It may not be spoken or sung. It might unfold in patterns of light, in electromagnetic pulses, in changes of temperature too subtle for us to feel. Yet the essence of the thought, is anyone out there, could be the same. In this way, curiosity becomes a universal thread, connecting minds across impossible distances. We often imagine advanced civilizations as logical, cold, purely technological. But intelligence does not erase emotion. It deepens it. The more a species understands, the more it has to contemplate. A Type 2 or Type 3 civilization, capable of harnessing the energy of stars or even galaxies, may still pause to gaze upward, wondering whether another mind shares the vastness with them. Knowledge does not end longing. Sometimes it amplifies it. And perhaps they dream of us without knowing our name. Not us specifically, but the idea of someone, another consciousness breathing quietly beneath a distant sun, another mind capable of asking questions. Another species trying to piece together the story of existence. They may not know we exist, but they may hope we do, just as we hope for them. The dream of other minds is not about contact. It is about companionship on a cosmic scale, the gentle belief that thought is not confined to a single world. It is the universe expressing itself in many forms, like different instruments playing variations of the same melody. As you breathe softly now, imagine drifting through the galaxy, passing worlds where alien civilizations think in ways both different and familiar. Some may be young, just beginning to observe their skies. Others may be ancient, their wisdom flowing through technologies we cannot imagine. Some may dream slowly over centuries. Some may dream quickly, like sparks of lightning. And perhaps, scattered among the stars, countless minds dream simultaneously, unaware of each other, yet united by the simple act of wondering. In that sense, even if we never communicate, even if we never meet, we are not alone. The universe may be full of dreams unfolding in parallel, separated by distance but connected by curiosity, reflection and hope. You, listening now in the quiet of your room, are part of that tapestry. One mind among many, dreaming gently beneath the same ancient sky. There is a soft paradox woven into the night sky. The more infinite the universe becomes, the less alone we feel. At first glance, infinity seems overwhelming, a vastness too large for comprehension, stretching in every direction, swallowing all sense of scale. And yet, when you settle into its quiet immensity, something unexpected happens. The vastness becomes comforting. The endlessness becomes gentle. Infinity begins to hold you rather than dwarf you. We often think of infinity as emptiness, but infinity is not an absence. It is a canvas, a space where possibilities are not limited to the small circle of our experience, but can exist in countless forms, unfolding across time and light. When you look toward the stars, you're not staring into a void. You're gazing into a universe filled with opportunities for life, consciousness, and stories beyond our imagination. Consider the night sky above you right now. Even though you may only see a few hundred stars with your eyes, there are hundreds of billions more in our galaxy alone. And beyond that, trillions of galaxies scattered like glowing islands across the deep ocean of space. Each galaxy holds its own swirl of stars, planets, moons, comets, dust. Each one a new stage where life might begin. Infinity is not sterile. It is fertile. In a universe this vast, loneliness feels less like a truth and more like a temporary perspective, a horizon created by our current limitations. Our tools cannot yet reach the nearest star, but that does not mean connections are impossible. Our understanding cannot yet decode signals buried in static, but that does not mean no signals exist. Infinity suggests that life may be rare on any individual world, but common across the boundlessness of the cosmos. When you breathe deeply into the idea of infinity, the edges of fear soften. You begin to feel not insignificant, but interconnected, a tiny part of a much larger tapestry, woven with threads that span galaxies and ages. The scale of the universe becomes a reminder that existence is shared, not solitary, that consciousness, in its many potential forms, might flicker wherever energy and time have the chance to collaborate. Infinity also removes the pressure of urgency. Whatever mysteries remain hidden today have time to reveal themselves. Billions of years stretch ahead, offering endless opportunities for discovery. There is no rush. The universe moves at the pace of stars being born, of planets forming dust by dust, of evolution unfolding molecule by molecule. In that cosmic timeline, our questions, including whether other minds exist, are still in their early chapters. As you breathe softly now, imagine drifting outward from Earth into the vastness beyond. The planet becomes small, then disappears. Stars grow closer, then scatter. Galaxies swirl like luminous storms, and through it all, you feel a sense of calm. Not because you are lost, but because you belong to something impossibly vast and unimaginably beautiful. Infinity does not erase loneliness, it transforms it. It shows us that we are part of a universe so generous with space and time that the question of being alone becomes not a fear, but an open invitation to wonder. The possibilities stretch out endlessly, and within them, comfort quietly blooms. There is a soft paradox at the heart of existence. The smaller we feel in the face of the universe, the more deeply connected we become to it. At first, the realization of our scale, a single species on a single planet, drifting around one sun among hundreds of billions, can feel humbling, even intimidating. But if you let that feeling settle, if you breathe into it slowly, it begins to shift. Smallness becomes not a burden, but a comfort. To be small is to be free from the weight of needing to understand everything. It is to know that the universe does not expect us to carry its mysteries alone. Stars will burn and fade with or without our permission. Galaxies will spin gracefully through cosmic time without asking us to guide their motion. The cosmos moves in grand sweeps, and we, in our smallness, are invited simply to witness, to feel awe, to rest in wonder, to let the immensity around us ease the pressure within. Human life unfolds in quiet, intimate moments. The warmth of a blanket, the sound of rain, the softness of someone's voice. We live in details, not in galaxies, and yet these small details belong to the same universe that swirls with nebulae and dances with gravitational tides. Your heartbeat is not separate from the cosmos. It is shaped by it, by the atoms born in ancient stars, by the chemistry carried through space, by the forces that weave the fabric of existence. To be small is to be part of something beautiful. Sometimes we imagine that significance comes from size or power or longevity, but the universe teaches otherwise. A single photon can travel across billions of light years. A tiny molecule can carry the code for an entire living being. A spark of consciousness, as brief as a breath, can reflect on the nature of infinity. Smallness holds its own kind of strength. Being small also means being protected. We do not need to face the full vastness of creation all at once. The sky reveals itself softly, through stars glimpsed between clouds, through planets that rise like lanterns, through questions that form gently in the mind before sleep. The universe gives us glimpses, not floods, moments, not all at once understanding. In our smallness, we are allowed to grow at a pace that feels human. And perhaps most beautiful of all, smallness reminds us that companionship matters. That connection between people, between civilizations, between minds, becomes precious precisely because it is delicate. If we were cosmic titans, spanning galaxies with ease, perhaps we would not cherish moments of closeness the way we do now. Our scale gives value to intimacy, to quiet conversation, to shared wonder beneath a sky that dwarfs us both. As you breathe softly now, imagine yourself standing under a wide night sky. You feel tiny, and yet that smallness is soothing. It melts the tension in your shoulders. It quiets the noise of the day. It reminds you that you do not need to solve the universe to belong to it. Simply by being here, breathing, wondering, you participate in its unfolding story. The paradox of being small is this: the more we recognize our smallness, the more spacious our inner world becomes. In that spaciousness, there is room for peace, room for wonder, room for a gentle, cosmic calm. When we look up at the night sky, it's easy to think of the universe as something separate from us, distant, unreachable, impossibly vast. The stars seem to belong to another realm, one far beyond the rhythms of our heartbeat or the quiet rising and falling of our breath. But the truth is softer, deeper, more intimate. The universe is not only above you, it is within you. Every moment of your life is shaped by ancient processes that began long before Earth was born. The atoms in your bones were forged in stars that lived and died billions of years ago. The iron carrying oxygen through your blood was once part of a supernova's fiery breath. The calcium in your teeth came from stars that collapsed under their own weight, scattering their elements through space. Even the hydrogen in the water you drink was created in the first minutes after the Big Bang, when the universe was still young, hot, and humming with potential. In this way, you carry the memory of the cosmos inside you, not as metaphor but as physics, as truth. Your body's a small gathering of stardust briefly arranged into awareness. Your thoughts are the universe reflecting on itself, shaped by the chemistry of ancient suns. Your heartbeat is a rhythm that echoes the first pulses of energy that flowed through the newborn cosmos. You're not outside the universe looking in. You are the universe, becoming conscious for a moment through a fragile constellation of cells. This understanding dissolves loneliness. It softens the boundaries between here and out there. When you think about life on distant planets, or civilizations far older than our own, you're not imagining strangers. You're imagining distant expressions of the same cosmic material that built you. Whether life appears on Earth, or Europa, or a world circling a distant star, its ingredients come from the same cosmic recipe. And so the question, are we alone, becomes intertwined with a quieter, more reflective question. How does the universe choose to know itself? Through humans, certainly. Through animals, through plants, through ecosystems that breathe and evolve. But perhaps also through minds we have never met, minds shaped by different elements, different skies, different histories. Life, wherever it arises, is made from the same fundamental dust. That means consciousness in all its forms is part of a shared lineage. You and a distant alien being, if such a being exists, would not be strangers but cousins born from the same cosmic womb. As you breathe softly now, imagine the particles within you glowing faintly, like embers. Imagine each one carrying a story billions of years old, a journey through stars, through space, through time. Those particles gathered into you, into awareness, into the quiet moment you are experiencing right now. The night sky is not something you observe from afar. It is something you are connected to at every level. You are part of its history, part of its chemistry, part of its unfolding. Let that truth settle gently within you. You are stardust, remembering itself. You are the universe, contemplating its own existence. And in that realization, the distance between you and the cosmos dissolves into something warm, familiar, and endlessly serene. We have drifted far tonight, through distant planets, ancient oceans, hidden technologies, and the quiet possibilities of other minds. And yet, as the journey unfolds, one truth becomes clear. No matter how far our imagination carries us, we always return to the same gentle question. Are we alone in the universe? It waits for us at the end of every theory, every discovery, every whisper of curiosity, not demanding an answer, but inviting reflection. When we began, the question may have felt heavy, like a weight pressing against the quiet corners of your mind. But now, after wandering through the vastness of space and the intricacies of life, notice how it has softened. It feels less like a problem to solve and more like a companion, a lantern guiding you through the unknown. The question has not changed, but you have. You are seeing it from a wider place, a gentler place. Perhaps the universe is filled with life, hidden in shadowed oceans, drifting through molecular clouds, or evolving silently on worlds warmed by distant suns. Perhaps civilizations rise and fall across epochs far longer than human history, their stories dissolving into starlight before ours begins. Or perhaps life is rare, so rare that Earth holds a singular role in the cosmic symphony, a lone instrument carrying the melody of consciousness through the void. Both possibilities carry beauty. If life is abundant, then the galaxy becomes a garden, diverse, ancient, and connected by the shared physics of existence. We would be part of a cosmic community, even if separated by time and distance. Our questions would echo across worlds, carried by beings we may never meet but who wonder as we do. If life is rare, then consciousness becomes even more precious. Earth becomes a unique cradle of awareness, a rare bloom in a universe of endless potential. In that scenario, our responsibility deepens, to care for our world, to honour our brief spark of awareness, and to explore with humility. Either way, the night sky retains its tenderness. As you breathe softly now, imagine the question floating beside you like a small, glowing sphere, not urgent, not heavy, just quietly alive. It reflects the starlight around it, changing subtly as your understanding grows. This question does not rush you toward answers. It simply asks you to keep wondering. Perhaps the universe wants to be discovered slowly, piece by piece, revelation by revelation. The way dawn unfolds over a landscape, revealing beauty gradually rather than all at once. Maybe that pacing is intentional. Maybe it gives us time to build meaning, to cultivate awe, to prepare ourselves for what comes next. And so we return to the beginning, but with new eyes. We hold the same question, but with a deeper stillness. We listen now not only with instruments, but with presence. The sky remains wide, the possibilities remain endless, and the question, our old, patient companion, remains open, glowing softly at the edge of understanding. As we journey through the possibilities of life beyond our world, another question slowly surfaces, not about what we will find, but about why we search at all. The universe is vast, patient, indifferent to whether we seek its secrets or ignore them, and yet something within us insists on looking upward. Something in the human spirit feels drawn toward the unknown, as though our curiosity is a quiet echo of the cosmos calling us home. The search is not merely scientific, it is emotional, it is personal, it is a reflection of what it means to be human. For thousands of years we have gazed at the stars with the same blend of awe and longing. Our tools have changed, from stone circles to telescopes, from radio dishes to spacecraft, but the desire behind them has remained constant. We are not just trying to answer a question, we are trying to understand our place in the story of existence. When we ask, are we alone? We are really asking whether our experiences, our joys, our fears, our questions are unique to this one tiny world. Whether consciousness is an isolated flame flickering in a vast darkness, or one of many lights scattered across the galaxies. And as we search, we learn something profound. The act of looking broadens us. It stretches our imagination, expands our empathy, and deepens our sense of connection. Even before we find anything at all. Imagine, for a moment, that humanity stopped looking. No more telescopes sweeping the sky. No more scientists analysing distant planets. No more deep space signals recorded in quiet observatories. The universe would not change, but we would. Our world would shrink, our sense of possibility would dim, the horizon would draw closer, not because the cosmos is small, but because we chose to stop wondering. The search reminds us that our story is part of something larger. It shows us that we are not bound by the limits of our daily lives, but connected to a cosmic lineage stretching back to the first stars. It teaches us patience, because answers may take centuries or more. It teaches us humility, because our planet is one among countless worlds. And it teaches us hope, because the very existence of the search suggests that we believe there is something worth finding. Even if no message ever reaches us, even if no craft ever descends from the heavens, the search itself enriches us. It brings nations together. It inspires generations to explore, to learn, to imagine. It reminds us that we are capable of asking questions bigger than ourselves, questions whose answers may lie beyond the span of our lives. As you breathe softly now, feel the calm weight of this truth settle into your thoughts. The meaning of the search is not dependent on its outcome. It is meaningful because we choose to seek. The cosmos does not require our curiosity, but our humanity does. Wonder is not optional for a species like ours. It is part of our foundation, part of the quiet flame that keeps us moving forward. Whether we are alone or not, the search gives shape to our place in the universe. It lets us stand beneath the stars, not as observers, but as participants, aware, questioning, and beautifully small in a universe that invites endless discovery. After all the questions, all the wandering, all the quiet drifting through distant worlds and invisible possibilities, a gentle realization begins to emerge. It doesn't arrive like a revelation or a bolt of certainty. It arrives the way dawn does, slowly, softly, almost unnoticed until the light is already there. The realization is this: the universe may never give us a single final answer to whether we are alone. And yet, the journey itself is already an answer. If life exists elsewhere, then the cosmos is a tapestry woven with countless threads of awareness, some ancient, some young, some still forming in the quiet oceans of distant moons. The idea fills the heart with wonder. It suggests that consciousness is not a rare accident, but a natural expression of the universe, arising wherever conditions allow. In this vision, we are part of a much larger family, connected not by biology, but by the shared miracle of existence. And if life is rare, if Earth is the lone cradle of thought in an immense sea of silence, then that too carries a profound meaning. It means consciousness is precious, a fragile light flickering in the vastness. It means our responsibility to care for our world becomes even greater, for we may be the only voice the universe has to reflect upon itself. In that scenario, our existence is extraordinary beyond measure, a singular bloom in an infinite field. Both possibilities, though different, hold their own kind of beauty. Both lead us to a soft truth. The universe does not need to be full of life for us to feel connected, and it does not need to be silent for us to feel alone. Connection comes from awareness, from curiosity, from the simple act of looking up. As you breathe gently now, feel how the question has changed. It no longer presses, it no longer stirs anxiety. It becomes a lullaby, an open doorway into peaceful imagination. Perhaps the answer is not meant to be discovered quickly. Perhaps the universe prefers to reveal itself slowly, letting each generation add a few more notes to the cosmic symphony. And maybe, just maybe, the soft answer is this. We are part of the universe, whether or not others walk beside us. Even in solitude we belong. Even in uncertainty we are connected by the stardust that forms every atom of who we are. The universe is not something outside us watching. It is something within us, unfolding. Somewhere billions of miles away, a planet turns beneath an unfamiliar sky. Maybe it holds life, maybe it is silent. Either way, it's part of the same story, carried by the same forces that shaped your thoughts, your breath, your quiet presence in this moment. The soft answer to the question, "Are we alone?" is not a conclusion but a comfort. Whatever the truth may be, we are held gently within the cosmos. We search because we are curious. We wonder because we are alive. And that in itself is enough. And now, after drifting through questions older than memory and possibilities wider than imagination, we return gently to the quiet of your own room, the small, familiar world where your breath rises and falls like a tide. Outside, night gathers softly. Whether the sky above you is clear or clouded, whether you can see the stars or only sense their presence, you rest beneath the same ancient canopy that has guided every thought we've explored tonight. There is something profoundly uniting in that. No matter where you are, in a city glowing with human light, in a countryside wrapped in darkness, in a quiet room where only the hum of life surrounds you, you share the same cosmic ceiling as every being on Earth. And if other worlds hold life, if other civilizations lift their eyes toward their own skies, they too would look into this same vastness, shaped by the same laws, lit by the same galaxies drifting through time. The stars do not ask who you are or where you come from. They do not ask whether you are certain or unsure. They shine with the same patience for all who look their way. In their light, faint, steady, ancient, there is no division, no loneliness, no question of belonging. The universe folds around you as gently as a blanket, not to answer every mystery, but to remind you that you are part of everything. As you breathe slowly now, imagine all those distant minds, real or imagined, resting under their own skies. Perhaps they too feel the weight of the unknown. Perhaps they wonder whether someone else is out there. Perhaps they look up with hopes and dreams shaped by suns we will never feel, and though the distances are immeasurable, the feeling itself is shared. Curiosity, wonder, longing. These may be the universal languages of consciousness. Tonight, as you drift toward rest, you can let the vastness comfort you. The universe is wide enough to hold you gently, long enough to outlive every fear, patient enough to wait for you to release the day. There is no need to solve every cosmic riddle. There is no need to hold the whole sky at once. You're allowed to set the questions down, to let them soften into the quiet rhythm of your breath. Feel your body grow heavier, like a small planet settling into orbit. Feel your thoughts drift like soft, untethered dust floating in a calm nebula. The night wraps around you. The stars, whether hidden or seen, remain your silent companions. You have travelled far in imagination. Now you return not with answers, but with peace. Let yourself rest beneath the same stars that have watched over countless generations and will continue watching long after this moment fades. And as you settle deeper into stillness, remember the final truth that every AstraFlow journey carries. Everything flows. Sleep in that motion. The journey tonight has carried you across distances far beyond any spacecraft, yet you have travelled gently, drifting through possibilities, touching ancient mysteries, moving softly between science and wonder. And now, with your breath slow and your body at rest, you find yourself returning home, not with urgency, not with conclusion, but with the quiet feeling that the question we began with has transformed into something more spacious, more peaceful, more deeply human. Are we alone in the universe? You can feel how different that question feels now. At the beginning, it might have stirred curiosity, or uncertainty, or a soft ache of longing. But after wandering through the vastness, through hidden oceans, distant suns, ancient civilizations, and the quiet potential of the unknown, the question settles like dust in starlight. You no longer reach for an answer. You simply rest within the wonder of the asking. If the universe holds other minds, they are part of the same cosmic story that shaped you. Whether they drift in oceans beneath icy shells, glide through skies of unfamiliar colours, or think in languages woven from light and mathematics, they share the same elemental origin, the same stardust, the same physics, the same mystery of awareness. In imagining them, you've connected with a version of existence larger than yourself. And if we are alone, if Earth is the singular cradle of consciousness in a galaxy of silence, that truth too carries a profound beauty. It means that your awareness, your breath, your quiet presence in this moment is part of something incredibly rare. A solitary flame flickering in the vast dark, precious precisely because of its uniqueness. In that scenario, the responsibility to cherish life becomes deeper. The meaning of our existence becomes sweeter. But perhaps the most important understanding is this: whether the universe is full or empty of other minds, you are part of it. You belong to its unfolding. You're a thread in its tapestry, a moment of reflection within its vast and ancient body. Tonight you have touched that truth. As you rest here at the edge of sleep, you can let your thoughts loosen, like stars drifting across the sky. You do not need to analyze or remember. You do not need to hold on to the details. The universe will continue its slow dance without you. And you, in turn, are free to drift into dreams. Feel your breath deepen. Feel your body soften. Feel the quiet gather around you like a dark, gentle sea. The stars, whether visible or hidden behind clouds and rooftops, remain above you, patient and unchanging. They do not ask anything of you. They do not need your attention. They simply shine, as they have for billions of years, waiting for you whenever you choose to look again. For now, you may let go. You may let the horizon blur. You may let yourself drift outward and inward at the same time, held by the same cosmic calm that fills the spaces between galaxies. And as consciousness begins to loosen its hold, as sleep approaches like a soft tide, let the final truth of AstraFlow settle over you. Everything flows. Sleep in that motion.